Picture this. You clock in for your regular shift. You're doing the exact same physical work you've done for years. Maybe you're assembling electronics, packing boxes, or inspecting garments. But as you work, every single micro-movement you make is being recorded, analyzed, and fed straight into a machine. Today, we're looking at a completely startling paradox. Human workers all over the globe are unknowingly generating the massive training data sets required to build the very robots designed to eventually replace them. It's literally a quiet revolution happening right under our noses.
I want you to just pause and think about that premise for a second. Are workers secretly training robots? Honestly, it sounds straight out of a sci-fi novel. But this isn't some far-off theory about the future. This is an active, ongoing phenomenon happening right now in manufacturing hubs across the world. So in this explainer, we're going to unpack exactly how this human data extraction actually works, who's footing the bill for it, and the profound economic impacts it holds for all of us.
Okay, here's a quick look at our agenda. We'll be covering the human data gold rush, what egocentric data actually is, the sudden rise of physical AI, India's unique position in all this, the labor paradox, and finally, the ethical implications of our automated future. Let's dive right in.
Section 1. The human data gold rush and the relentless pursuit of human behavioral data. You see, massive data collection isn't just the thing that happens on your web browser anymore. It's actively moving into our physical spaces, factories, commercial kitchens, warehouses, and garment facilities.
And the absolute key to all of this is something called egocentric data. Now, this is not your typical grainy security camera footage mounted way up in the corner of a room. Now, egocentric data is sensory and video info collected entirely from a first-person perspective. It captures exactly what a worker sees and what a worker does in real time. And for researchers, this is an absolute goldmine because it records all the subtle nuances, the human decision-making, the intricate hand movements, the real-time problem-solving, stuff that overhead cameras completely miss.
So to get that first-person view, workers are being outfitted with some serious wearable tech. We're talking head-mounted cameras, smart glasses, body cams, and even highly precise tools like eye-tracking devices and hand-tracking gloves. These wearables basically act like digital sponges. They're just soaking up the physical expertise of the human body hard at work. Moving on to Section 2, Understanding Egocentric Data. Let's look at how these AI systems actually translate that human behavior into machine learning. To really wrap our heads around this, we have to contrast two totally different flavors of AI. Now, you're probably super familiar with large language models, right? They learned by scraping massive chunks of text and photos from the internet. But physical AI, humanoid robots that actually have to navigate the real world, they need a completely different diet. They can't just read a Wikipedia page or an instruction manual. They absolutely need first-person demonstrations of physical work to learn how to deal with gravity, weight, and totally unpredictable objects.
And that brings us to a crucial process known as imitation learning. Let's break down how this works step by step. First, a human performs a task. Now, whether they're picking up a screwdriver or folding a shirt, they are making thousands of tiny, subconscious micro-decisions. Step 2, the wearables capture all of it. How much force was applied? How did the worker adjust their grip so they didn't drop the item? How did they recover from a slip? Finally, Step 3, the robot algorithm watches these millions of demonstrations and learns the overarching patterns. It's essentially just mimicking human expertise.
All right, Section 3, the rise of physical AI. The tech industry is heralding this as our next major technological revolution. So the question is, who exactly is gobbling up all this data?
Well, industry analysts point out that to train a genuinely useful humanoid robot, you need millions, literally millions, of human demonstrations. And the major players pouring billions of dollars into this exact pursuit are heavy hitters like NVIDIA, Tesla, Figure AI, Agility Robotics, Boston Dynamics, and Meta. They're locked in this absolute arms race right now, sparking a global rush to capture human movement data to power the next generation of industrial robots and warehouse systems.
Which leads us to Section 4, India's unique labor position. This is the geographical epicenter of human data, because this phenomenon, it is absolutely not confined to some shiny labs in Silicon Valley. India actually occupies an incredibly vital position in this whole transformation. The country is home to some of the absolute largest manufacturing workforces on the planet. Cities like Bengaluru, Ahmedabad, Chennai, Pune, and Noida are constantly popping up in automation studies. Why? Well, India's massive garment clusters and electronics assembly plants provide exactly the kind of highly repetitive yet extremely skilled manual labor that robotics developers are desperate to study. Think about it. An electronics assembler might perform a precision task thousands of times a week.
every single one of those actions becomes a highly lucrative piece of training data.
Okay, Section 5, the labor paradox, or what economists call knowledge extraction automation. This shift sets up an incredibly complex and honestly somewhat unsettling economic dynamic. Economists have highlighted this really fascinating shift when you compare historical automation to modern AI. Look, historically, automation replaced physical effort, right? Think of farmers who tested early agricultural machines or factory workers working with early assembly lines. The machine replaced the muscle. But modern AI, it's a whole different ballgame. It's trying to replace the expertise itself. The worker generates the knowledge, the AI absorbs that knowledge, and then the resulting automation could eventually reduce the demand for those exact same workers. It's a profound paradox that is very likely to redefine what job security even means for us down the road.
That brings us to Section 6, Ethics and the Future. What exactly is the human cost of physical AI? Looking closely at the source material, there are some major academic and labor concerns popping up that we need to talk about.
These big ethical concerns generally fall into 3 buckets. First up, informed consent. Sure, workers usually know they're on camera, but do they actually grasp that their footage might be actively training an AI system, or that it could be sold off to third parties? Second is job displacement. Groups like the International Labor Organization are actively warning that routine manufacturing jobs are facing severely elevated automation risks. And third, maybe the trickiest of all, is data ownership. This whole situation has led some scholars to theorize about a concept called digital colonialism. Just think about how resource extraction has shifted over time. Back in the 20th century, the global economy was fueled by extracting oil, minerals, and agriculture. Fast forward to the 21st century, and the most valuable resource might actually be human-generated data. The big concern raised by academics here is that developing nations might just become the raw suppliers of human behavioral data, quietly feeding algorithms that are entirely owned by a handful of massive tech giants.
But hey, before we completely declare the end of human labor, let's do a quick reality check. The researchers who actually study this stuff heavily caution against these simplistic, overly hyped doom and gloom narratives. The truth of the matter? Robots still struggle immensely with tasks that are ridiculously simple for you and me. Humans and robots are definitely going to be coexisting for years to come.
Because right now, tasks that totally baffle billion-dollar machines include folding clothes, washing dishes, handling fragile objects, or sorting a bin of mixed items. Seriously, a cutting-edge robot can be entirely defeated by a fitted sheet. A task that a human learns in 5 minutes might take thousands upon thousands of separate demonstrations for a robot to even kind of master. Human brain and hand coordination is an absolute marvel, and machines are still fumbling around trying to replicate it.
However, if we look at the timeline, the future trajectory of this tech is pretty crystal clear. Camera costs are dropping like a rock. Wearables are getting vastly more sophisticated. Computer vision is advancing rapidly. Humanoid robotics are scaling up, and the investment in industrial automation is just skyrocketing. The collection of first-person worker data, it's not slowing down. In fact, it's guaranteed to expand dramatically over the next decade.
So the central question is no longer whether robots are going to learn from humans. That's already a done deal, it's happening. The real question is, who owns human skills once they're digitized? Will the workers, the people whose literal physical knowledge is powering this next generation of AI, will they be given a share in the immense economic value they are actively creating? It's a massive question touching on labor rights, economic justice, and the very future of how we work. Thanks so much for joining me for this explainer. Keep asking those big questions, and I'll catch you next time.